Hello students, in this video we will discuss about solution of exercise 13.2 from the chapter surface area and volume. In this video we will discuss about solution of question number 1, 2, 3 and 4. So let us start with question number 1. The question is, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in the term of pi. Okay. So, as you can see in the figure, this is the shape. Okay, this is the total shape. As you can see, this cone is standing over the hemisphere. The radius of hemisphere and cone is equal and it is 1 centimeter. Now, height of the cone is same as radius. That means you can say height of the cone is also 1 centimeter because radius of the cone is equal to 1 centimeter. So, you got for cone, okay, radius is equal to 1 centimeter and height is equal to 1 centimeter. Okay. And for hemisphere, okay, for hemisphere radius is equal to 1 centimeter. Now, you have to find the volume of the solid. As you can see, the volume of the solid can divide in two parts. One is volume of the cone, okay, volume of this cone plus volume of this hemisphere. Okay. So, from the given data you will find the volume of cone and volume of hemisphere respectively, and we will add these two volume, then you will get the volume of solid. So, let us check the solution. All the data are given here. Volume of solid is equal to volume of conical part plus volume of hemispherical part. Volume of conical part, the formula is 1 by 3 pi r square h, and the formula for volume of hemispherical or hemisphere is equal to 2 by 3 pi r cube. Now, you have to find the value in term of pi. It is given in the question. You have to find the value in term of pi. That is why you will not put any value in place of pi. In place of r and h, put the value 1 and 1 respectively, and here also the value will be 1. So, if you do the calculation, the answer will be pi centimeter cube. Okay, in this way you have to solve question number 1. Now, question number 2, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, find the volume of air contained in the model that Rachel made. Assume the outer and inner dimension of the model to be nearly the same. Okay, look at here. This figure is the combination of a cylinder and two cone fixed at the end of the cylinder. Now, it is given that the diameter of the cylinder is equal to 3 centimeter. So, as well as the diameter of the cone is also 3 centimeter. So, you can write for cone, okay, for cone, 1 minute, for cone radius will be 3 by 2 because diameter is given as 3 centimeter. That is why radius will be 3 by 2 centimeter, which is equal to 1.5 centimeter. And look at here in the question, it is given that the height is equal to 2 centimeter. Okay, look at here, using the diameter is 3 centimeter and the length is 12. each of the cone of height 2 centimeter. That means you can write height is equal to 2 centimeter for the cone. Now we will discuss about cylinder. Okay. For cylinder, as you can see, the diameter of the base is equal to diameter of cone, that is radius will be 3 by 2 centimeter, which is equal to 1.5 centimeter. Now we need to find the height of the cone. Okay, height of the cone. Look at here, from here to here it is 12 centimeter, right? Total is 12 centimeter. Now from here to here it is 2 and from here to here it is 2, because the height of the cone is 2 centimeter. Therefore, the height of the cylinder will be from this position to this position. Okay, and the value of this height of the cylinder will be 12 minus 2 plus 2. Okay, you have to deduct this length and this length from 12. So, the resulting will be 8 centimeter. Okay. So, the height of the cylinder will be 8 centimeter. So, I can consider it is 8. I can consider this notation as H1 because I have used H here also. Okay. So, these are the given data of the figure. Now, let us check the solution. As you can see, height of the conical part, then radius of the conical as well as cylindrical part, and height of the cylinder is given as 2, 3.2 and 8 centimeter respectively. Now, you need to find the volume of air contained in this model. Obviously, the volume of the air contained in the model is equal to the volume of the whole model, and the volume of the model can divide in 3 parts. One is volume of the cylinder. Okay. Next is volume of this cone, this right hand side cone, and next the volume of this cone. Okay. Or you can write volume of cylinder plus 2 into volume of cone, because these two cone are in same dimension. So, volume of air contained in the model is volume of cylindrical part into 2 into volume of conical part. Now, just put the formula of volume of cylinder pi r square h, and volume of conical part is 1 by 3 pi r square h1, because for conical part you have considered height as h1. Now, just put the value, and in place of pi put 22 by 7, answer will be 66 centimeter cube. Now, question number 3. A gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup could be found in 45 gulab jamuns, each shaped like cylinder with two hemispherical ends with the length 5 centimeter and diameter 2.8 centimeter. So, here in this slide we will discuss about the shape of the gulab jamun. How many gulab jamuns are there? 45 gulab jamuns are here in this container. Now, these gulab jamun are in the shape of cylinder with two hemispheres. So, it is looking like in this form. Okay. This will be the rough diagram of the gulab jamun, where the ends with length. So, where this length is given as 5 centimeter and diameter is given as 2.8. So, you can say this pink position, this is the diameter of this gulab jamun is given as 2.8 centimeter. So, you can easily say that the radius this gulab jamun is this gulab jamun is made by one cylinder and two hemisphere, and for these three parts the radius is equal to 2.8 by 2 centimeter, that is 1.4 centimeter. Okay. Now from here to here it is 1.4 and also from here to here it is 1.4, right. From here to here it is equal to the radius of the hemisphere, from here to here it is also equal to radius of hemisphere. Okay. So, height of the cylinder, I am denoting it by h, height of the cylinder will become 5 minus 1.4 plus 1.4, that is 5 minus 2.8, or you can say 2.2 centimeter. So, height of the cylinder is 2.2, radius is 1.4. So, you can easily find the volume of this section. Again, from the radius is equal to 1.4, you can easily find the volume of this hemispherical section. Okay. So, let us check the solution. Radius of hemisphere is 1.4, height of the hemisphere as well as radius of hemisphere is 1.4, this position from here to here, from here to here it is 1.4. Now, height of the cylinder will be 2.2, I explained it in the previous slide. Now, the volume of 1 gulab jamun will be volume of cylinder plus 2 into volume of hemisphere, volume of this cylinder plus 2 into volume of this hemisphere. Now, just put the formula and put the value of R and H. You will get the volume of each gulab jamun as 25.05 centimeter cube. Now, how many gulab jamuns are there? 45. So, the volume of 45 gulab jamun is 45 into 25.05, that is this much. Okay. Now, in the question look at here, the gulab jamun, a gulab jamun contains sugar syrup up to about 30% of its volume. Find the approximate how much syrup would be found in 45 gulab jamun. Okay. That means 1 gulab jamun is containing 30% of its volume. Similarly, 45 gulab jamun contains 30% of their volume. So, the 30% of the volume of 45 gulab jamun will be 30 by 100 into this volume. Okay. Just put it here. If you do the calculation, it will be 338.177 centimeters cube. That means the volume of sugar syrup will be 338.17 centimeter cube, because each gulab jamun containing 30% of its volume. That is why 45 gulab jamun will contain 30% of the volume of 45 gulab jamun. Okay, this way you have to solve it. Now, question number 4, a pen stand made of wood is in the shape of cuboid with 4 conical depression to hold the pens. Look at here, in the diagram it is given, these are the conical holes. Okay. The dimension of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. That is the height, length and breadth of this cuboidal shape is already given. Okay, it is length is equal to 15 centimeter, breadth is equal to 10 centimeter, height is equal to 3.5 centimeter. Now, the radius of each of the depression of is 0.5 centimeter and depth is 1.4 centimeter. That means, for these 4 conical holes, okay, for these conical holes, for each of them radius is equal to 0.5 centimeter and height, I am considering it as h1 because h is already here, is given as 1.4 centimeter. Find the volume of the wood of the entire stand. This one is very easy. First of all, you have to find the volume of this whole cuboidal. You have to find the volume of this whole cuboidal pen stand. Okay, and then you will find the volume of each cone. If you can find the volume of each cone, you can easily find the volume of 4 conical hole by multiplying it. Then you will subtract the volume of this 4 conical hole from the volume of entire cuboid. Okay. So, let us check the solution. All the data are given here. Volume of the wood in entire stand is volume of cuboid minus 4 into volume of depression, or 4 into volume of conical depression. So, the volume of the cuboid is L into B into H, and the volume of depression is 1/3 pi r square H, where this H is equal to 1.4 centimeter. Now, just put the value to the calculation, it will be 523.53 centimeter cube. So, this was the last question for today's video. So, this is all for today. Thank you.